turn it over to our speaker tonight, Mr. Andy Cowell. Going to, I guess, open up the mystery of NoOps to us. So give him a round of applause.
Okay. Yeah. There we go. My clicker died, so I've got to do this the old school way. All right. My name's Andy Cowell. I have been in IT and IT operations and engineering for almost my entire career. I was a C developer for 3 months, so I get to claim I was once a professional developer. But most of my career has been systems administration, network administration, virtualization, cloud engineering, and now I've, for the last 4 or 5 plus years, I've managed cloud engineering for Discovery, a cloud engineering team. I've done a fair bit of stuff, you know, from both small companies to large companies, different technology stacks. So I've been doing this a while. So part of this talk is going to be about how IT engineering and operations has evolved over time. Far enough back, IT engineering was assembling the computers themselves. That predates me. So I want to, you know, respect what's gone before me, but I can't really talk about that.
I have one of those, by the way.
Really? I just searched for antique soldering iron, and that's what came up. I kind of missed this era too, right? Punch cards, I came in right after that. I saw those laying around, but I never got to actually use them.
I took a Fortran 4 course using that punch key punch.
Wow.
And this really starts the era that I can start to address, right? So this is compiling the Apache web server from source, nice. Right? So I'm going to call this traditional systems administration, right? So kind of when I started, what we tended to see were big servers used by multiple users, usually shelled into that system, running things on that one server. So multi-user systems. You know, the question, if we were going to buy more hardware, is like, you know, should we buy another server? Like, we bought servers one at a time, and they tended to be big servers. Software tended to be compiled from source code. We could buy software and it would be distributed as a binary, but most of the time, if we were installing Apache or some sort of open source software, we would compile it from the source code. We would have to go track down all the dependencies from wherever they were hosted, download those, compile those dependencies, you know, and somehow make it all work together. We had multiple architectures. So we were doing this on, you know, Sonos, doing it again on HP UX, doing it again on OSF. Of course, inevitably, what you were trying to compile had not been compiled on your architecture before. So you wound up having to go into the source code and patch it to make it work, right? And then you would typically go to each server individually, do like a make install there. You know, you could maybe tarball some binaries around if it was easy enough. Manual configuration changes. We went to each server and manually configured the server how it needed to be configured. Monitored via syslog. And your backups really meant scheduling one night a month when you took the server down, right? So you had a quiet file system and backed it up to directly attach the tape, right? So over time, actually, anybody have any other characteristics that they want to add? Have I missed anything or unfairly treated anything?
A lot harder to recover those type of systems.
Oh yes, yeah, yeah. My anecdote for that was we went to do a recovery one time, and we had multiple volumes written to the same tape, but the only volume we had was the last one we backed up.
Oh, no.
Because the device we had used was, RS301 instead of NRS301. We'd use the rewinding device, not the non-rewinding device. So rather than writing these like chapters in a book, we backed up a file system, rewound it, backed up the next one, rewound it, backed up the next one, rewound it. So fun times. I'm glad I was there, but I don't miss them.
I've heard tales of the proliferation of a whole lot of other types of networking aside from the ubiquitous TCP/IP on Ethernet we have now.
Yeah. Had 10 base 2 BNC connectors and had a building go down one time. All the networking in a building went down. Troubleshooting it was, I would go to the first office, I would disconnect that computer, I would call somebody, he's like, is it working yet? No. Plug that computer back in. Go to the next one, disconnect it, call them. Is it working yet? Trying to track down which was the problem. Great war stories, but it's a better world now. What changed? What this is sort of my attempt to look at generations of sort of operations, right? So the next generation to me is kind of characterized by Linux and package management. And this is what we probably fairly call modern systems administration, right? We no longer buy a server, right? We would buy, are we going to buy 5 servers? Do we need 6, 5, 10? We would debate kind of how many. And we're buying larger systems than we used to, but I think in sort of relative terms, it's not like the big hardware you can get today. Like in relative terms, they're smaller computers, right? Users rarely log on to these systems, right? They tend to consume things through services. The big kicker for me is you no longer compile software, right? We kind of consolidated on Linux, right? There's still other things out there, but by and large, most people are running Linux. And you can get pre-built packages for your system. Those different architectures, like you won't always get everything you want, but 90% of your needs are covered by pre-built packages that you can just install. You don't have to go in and patch it yourself. You don't have to understand programming to be a good systems administrator. You just install the right packages and configure them according to the documentation, and you're good to go. Monitoring's changed. It's now distributed. Our syslog versus other things. Backups tend to be centralized through a backup server. You've now got file systems. You can do snapshots. You don't have to take the server down in order to get good backups. So things are better. Anybody have anything else to add? All right, so you'll have to excuse me. I got to look ahead a little bit. This was a very short notice presentation. I should have mentioned that. We found out our original scheduled speaker was out yesterday, so I had to kind of throw this together. I'm not sure if that was in there intentionally, or if it was left over from the previous talk. But has anybody here actually participated in building a data center? Yeah. Like it's an ordeal. Like it is a long-term, cost-heavy thing, right? Time-consuming, expensive, and difficult, right? And we can compare that. The data center is sort of all the things that have gone before, right? About the time that the traditional or the modern systems administration is in full-fledged, we start to get the cloud, right? So we don't have to necessarily build data centers anymore. We could potentially use the cloud. So we're going to spend a minute and talk about what the cloud is. That's the NIST definition of the cloud, right? But if you go down there, on-demand self-service, broad network access, resource pooling, rapid elasticity, measured service, it's Amazon is pretty much defining what the cloud is, right? Over time, that other cloud providers do some things better than AWS, but AWS is really the leader, and they're sort of defining what it means to be a cloud provider. This is the Gartner Magic Quadrant. Right, I'm a manager. I'm contractually obligated to present the Gartner Magic Quadrant every chance I get.
As a manager, you need to update your Magic Quadrant.
I'm about to. This is the Magic Quadrant. This is the Magic Quadrant from 2015. Yes, that's intentional.
Okay.
And I mean, you can see if you're not familiar with the Magic Quadrant or the Magic Quadrant, Gartner is an industry analysis firm, and they'll basically charge you thousands of dollars to give you this slide and a big write-up about it so that you can kind of look at it and see, what do they think are sort of the leaders in this cloud space, right? The horizontal axis is vision, completeness of vision. How complete is this company's vision of infrastructure as a service? And the ability to execute is the vertical axis. So if you're up in that top right quadrant, you're a leader. And the further top right you are, the more you're a leader. And you can see Amazon's the leader, Microsoft a close follower, and everybody else is sort of left behind. And now, just 4 years later, summer of 2015 to summer of 2014, what does it look like? 2019, sorry. Right. I mean, where's Joanne? I know. Yeah. So, yeah, I mean, they're falling like flies. The cloud is sort of consolidating. I can't imagine Oracle will stay up there a whole lot longer, but who knows? I might be wrong. I question Google's placement. But yeah, I mean, AWS is sort of the de facto cloud standard. Common criticism of the cloud. Right? There is no cloud, just other people's computers. And I just want to draw attention to this. This is really, I think, a privacy criticism. But a lot of people throw this out. And I think the thing to remember is 30 years ago, we had other people's computers. Right? We could have outsourced all our data centers however many years ago. And, IBM wasn't getting double-digit growth year over year, outsourcing to anybody, right? So, there's more to it than just other people's computers. And Etsy is the typical counterexample that I give. So Etsy, John Alspal used to be, I think, the CTO-ish, but they have a very DevOps culture. He became sort of a DevOps darling because he operated in a very cloud-like manner, but he did it all on-prem, did it all with his own physical hardware. So it's not just other people's computers. And I think, in my mind, these are the key parts of that misdefinition, right? The consumer can unilaterally provision computing capabilities, right? They can do it on their own. They don't have to ask anybody, right? As needed automatically without requiring human interaction. Do it on their own and through standard mechanisms. Right? In my mind, what that means is you've got an API-driven infrastructure. Right? We've got things we didn't used to be able to provision through an API that now we can. Right? I can give each and every one of you your own data center, and you can go do whatever it is you want in that data center through API, spin up load balancers, servers, DNS, CDNs, AI services, whatever. Amazon's got like 170 something services, I think. You just go do it all, and you don't have to talk to me. Right? And you're not going to affect anybody else in the room because you're isolated in your own virtual data center. Any questions about that? I have obviously wowed the audience.
So it seems like you skipped just traditional on-prem or VPS virtualization services where they're not they're not this,
Mhm.
right? But they're not me having to buy and racks.
That's a good point. I would characterize it as modern systems administration, right? Because it was easier to provision. It's true, but once they were provisioned, they tend to be managed the same way. And typically, in my experience, it was not the end user provisioning it on their own, right? Even when you had API access, I used to be in that position. We had to be very careful about the storage on the back end. We had limited amounts of storage. We had to be careful where these virtual machines landed. We had to be careful that people didn't over provision the server. So it was a different world, right, than this, in my mind. Those virtual machines look more like modern systems administration rather than what comes next. With that API-driven infrastructure, or the cloud, right, there's no barrier between the end user and virtually unlimited infrastructure. Right? Implication being like what I told you about. That end user can go do whatever it is they want, whenever they want to do it. In sort of the older models of operations, IT bought the servers. Right? So if somebody needed a server, they had to come to us, and we would kind of tell them what they could get, or work with them to figure out what it was they could get. We had to check the data center. Was there power? Was there cooling? Was there networking? All those facilities-based things that delayed implementation for the end user. And even if all that was in place, it was still typically 90 days to get the hardware in. Right? Today, an end user can put significant infrastructure just on a credit card. Right? So all these developers have got their own purchasing cards to their company and just go to Amazon, build out their own data center in a few minutes, and by the end of the day, they've got infrastructure in production. The nice thing about that is, a lot of times, IT is viewed as a cost center, right? Because we have to go and, it's one more thing that developers have to go and spend money on in order to get a product out the door. Right? But if the developer is buying it, it seems more like it's not an outsourced cost, right? It's the same way that you buy a developer, you pay a developer salary and it's productive, right? It seems more in line with that sort of top of line productivity thinking rather than an external cost somewhere else. And when they can do that, it gets that traditional IT out of the way. Right? There's one less barrier between that developer and getting that product out the door. Which sort of brings us to DevOps. So what is DevOps? Simple, right? DevOps is a particular type of IT operations directly in support of developers. Is the simplistic definition. There's a bigger one. It aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. Letting developers get that product out the door. And you may say, well, I don't support developers, right? This is that is a different world. And it is, but there's a lot of tools and techniques that everybody can take away from DevOps and apply anywhere, right? Sort of like infrastructure as code. The ability to have a data structure. Well, anecdotally, when I first moved into the cloud, I had a team of individuals who'd never done anything in the cloud. So I got a physical Staples easy button, with a red button, you hit it and it says, that was easy. I put a little Wi-Fi chip in there, And when you hit it, I had to connect to another server and launch a CloudFormation template, right? Infrastructure as code. So when I hit that button, DNS was configured, servers were brought up behind load balancers, content was pulled down from the web and dropped on those servers. And within 10 minutes, everyone was able to pull up something that didn't exist before, right? That infrastructure as code concept kind of comes out of DevOps, but you could use it, for example, if you're punching out customer sites, right? You can see exactly, you can have that button, the customer pushes that button, they get their site delivered to them within minutes, right? So there's a lot of good ideas there, even if you're not working directly with developers. There's a lot of good things to take away. I think it's a sort of a marriage. There's a lot of good ideas coming out of traditional operations like configuration management that becomes part of what DevOps tends to do. And then there's a lot of good ideas like CICD that's really more for DevOps is coming back into modern systems administration. Any questions about that?
How did you configure DNS with the easy button?
AWS service, Route 53.
No, I mean you have to swap something out between different strokes of the easy button to deploy the same. You got to configure the template.
In that case, everything was hard-coded.
Oh, okay.
Yes.
Okay.
In that specific case, everything was hard-coded.
I want to be able to replicate this.
Well,
So you need a knob on the side of these.
Yeah, you need a knob.
yeah, I mean, in reality, whether you're using CloudFormation or Terraform, they take variables.
Sure.
So I can have the same infrastructure. I can change the domain name and spin it up multiple times.
So you have to do that under the table and then present the.
Only-
it's a good trick.
Only in that case,
Okay.
right? The purpose of that was not to have a general purpose infrastructure, right? The purpose was to demonstrate to people who hadn't used the cloud before what we could do.
You just need a Morse code driver.
There you go.
That would not turn people onto the cloud.
I just had a comment like with the DevOps stuff, and specifically someone spoke a few months back about the whole infrastructure as code. And another thing is versioning, I guess was mentioned there, even with infrastructure like configuration. So I thought that was an interesting way to look at DevOps too, where you're pushing out like network configurations across your on-prem, but then you're also using versioning to like the development side.
Yes, absolutely.
So,
So you may answer this later on, but you're talking about infrastructure as a service. Do you see, what use cases do you see these days for building your own infrastructure on site?
So I work in the cloud. I'm all in on the cloud. I love the cloud. But everything in technology is a tool or a solution rather than like a moral right or wrong thing. Like it's always a cost-benefit analysis. In our case, we already have numerous data centers built all around the world. There's already a sunk cost there, right? For us, a lot of times it makes sense just to put things in the data center, right? If we don't need the advantages the cloud brings, the cloud's just more expensive, right? If we're going to set a Windows server out in the cloud and run it 24/7, not scale it out, not do any sort of cloud automation around it, stick that thing in the data center. We don't need to do that. At the same time, if I were starting from scratch and I needed that exact same server, like why would I go put it in a data center somewhere, right? It may make more sense to put it in the cloud. So, it's totally a cost-benefit analysis based on your particular situation, right? There is no right or wrong answer. It's just what's best for you.
I was gonna say, as someone who works with a lot of small businesses, their preference is to have something. Yeah, like at least for QuickBooks and accounting and SQL, whatever. We've got a lot of people that just prefer to have something in their office that they're running their infrastructure off of.
the cost is a concern in the cloud. I mean, even if they want to go that way, it may not work out for them. So they need that much resources.
And my standard spiel is, that Amazon will come in and it will tell you that you will save money going into the cloud. And that's only half the story, right? You will save money going into the cloud someday, right?
Yeah.
But if you simply take what you do today and you do it in the cloud, it's going to cost you a lot more money, You have to operate differently in the cloud, and you can absolutely be, you can save money, you can be more reliable, you can be all these great things in the cloud once you learn how to use it effectively, right? And that's essentially what I think these people are saying, right? And I've seen it in large enterprises too. It's like they don't want to learn how to do anything differently in the cloud, so it's just costs more, right?
I would think too, and this shows maybe some of my ignorance on the cloud side, but like if you have an environment that's all Windows servers versus like they can go 100% Linux, well, I think Linux makes a lot more sense in the cloud cost wise. Because you're paying those Microsoft licenses in the cloud as well, they cost way more. So
It's not just that. I mean, in my experience, and I'm not a Windows guy, I'm not trying to knock Windows. I had a blended team for a long time, which is both Linux and Windows, and I really tried to treat Windows as a top tier operating system, just like Linux. It was just harder to automate anything around Windows. We would come up with this great plan to put something in the cloud. It's like, oh, well, I got an installer I have to click through. That's, it's just everything was just more difficult.
That was years ago, though. That's not necessarily true.
So the last time.
I know they put Linux on it. So it's a lot easier.
I can easily put Automation Suite on the Linux box, though.
Yeah, well, I wouldn't let you.
I think licensing wise, just unless you're going like Red Hat or something, Microsoft, it's just expensive.
Azure would like to tell you differently.
Oh, sure, yeah.
Well, that's the great thing about Azure. Now Microsoft's getting money for Linux. Right. And
They run more Linux than Windows.
That's the same argument I've had with my teams. Like, stop arguing about Linux versus Windows. Right? We're moving up in the layers of abstraction. It used to be we build our own computers, right? And then we got programmable microcontrollers, right? And then we got these operating systems that can run on top of it. It's like we're moving up the stack. I mean, we're deploying things now on cloud-like platforms, whether it's AWS or Azure or Kubernetes. Like, so if you're going to fight about something, fight about that.
Yeah. So I know this isn't your team, but are you guys starting to do any type of cloud bursting or offloading for the video editing and video storage? Because I know that tends to be a sticky wicket.
So we are entirely in the cloud.
Including for the video edits?
Absolutely. Not for the video editing. This is true. All our linear play out on the TV channels is in the cloud. Editing is not.
So do you do anything like archival storage out there?
Yes, all our videos are in the cloud. Yeah. I don't know how many petabytes we've got in S3, but it's several. Yeah.
So you persist everything in the cloud too?
Yes.
S3?
Yes.
Does it cost less than storing on site?
That's a great question.
Probably no.
Yeah.
That's a Dropbox question.
But the thing is, I mean, the alternative is like, EMC's Isilon, like that's not cheap either, right? And then it's also the cost of, staff to actually manage that, and
And the opportunity cost of losing all this cool stuff you can do while having it up there.
Yeah. I mean, if you think one Isilon system is expensive, I mean, it's right over here. Like, we have another one that's geographically distant from that. It's twice as much. Yeah. I did not hear a lot of complaints about that money.
How often do people bring up questions of liability in cloud hosting? Because, like, for example, I've got a project that I'm just in the process of getting started. We're going to host it ourselves. Like, I've got some hardware that I'm running myself because of some of the data that we're storing. I don't feel comfortable putting it out elsewhere, but that's also my own certain levels of paranoia and security. Working with clients that host stuff in the cloud and see, things that have happened to people who made mistakes, various things like that.
So we don't deal with HIPAA data or anything too particularly sensitive. So, I mean, I don't think there's much concern about that.
Andy, can I comment on that?
Yeah.
So all the big cloud providers have like SOC and PCI and all that stuff. Amazon has got a list of all the, I'm not a fan of theirs, but they have like all of the certifications they've got European data certifications from all over the world. So if you need for your business to prove compliance for some set of criteria or another, they will be able to tell you yes or no whether they can handle that. And Amazon, for most of them, the answer is yes.
Yeah, that's
That's
true.
for the platform, though, not for your system.
That is true. Well, so
Yeah.
but most of those are around the facilities themselves, right? So that's sort of like, and that's something that you don't have probably running a few servers in your office.
You're all just trying to.
I've always heard that the cloud turns into a question of, did I build the right thing from a security perspective to did I configure the thing correctly?
I think Ring is a great example of this right now.
Yeah, that is actually a really great example. Their problem is not that they're using the cloud. The problem is that they have it configured so people can do nasty things.
Yeah.
Or Wemo right now is a caching issue where they've got things that shouldn't be cached, and people can get other random people's camera streams.
That's why it's not Wing.
It's a lot of the same problems. It's just that bigger scale and it moves a lot faster. All right, so key concepts of DevOps. Breaking down silos, you hear this a lot.
Can I get that on a sticker?
So I had a technical person in a particular company that had to deploy a MySQL database in a development account. Right? 5 minutes, right? But he's not on the database team. So he goes to ServiceNow, goes to the database request form, downloads a Word document with all the information that you would need to be a DBA to understand anyway, fills it all out, attaches it to the ServiceNow request, sends it to the database team. Right? So this database team is a silo. Right? They work on their vertical, which is databases. Right? Well, they look at it, and they said, well, this is in an AWS account. That's in the cloud. So we got to send this to the cloud team. Right? After sitting in their queue for a week before they get to it, they realize, it's in the wrong team. So they go to the cloud asset request form. They download that Word document, which has got everything in it that you'd have to be a cloud engineer to understand anyway. They fill it all out, attach it to the ServiceNow request, submit it to the cloud engineering team. And a week later, it gets picked up by a cloud engineer who looks at it and says, it's going to have a firewall open. And so he goes to the firewall request form.
It missed a step. It didn't go to operations yet, though.
Yeah. So, at some point, you have to have specialization and expertise. But you got to try and drive that as far down the chain as possible. Right? You have to enable people. You don't protect people by setting out silos. Right? Protect people by lowering the blast radius by giving them their own dev account. Right? Where you can tell that guy, what are you coming to me for? Go, it's MySQL. You can do it. Go do it. Right? You do it in your account. The only person you're going to hurt is yourself.
So what you were saying that's another advantage of using cloud type.
Absolutely.
Stuff, right?
When I was a network engineer, I could not let people touch the networking equipment because one malformed port could take the entire data center down. Right? In the cloud, when I'm giving each one of you your own data center, the only person you're going to hurt is yourself. So if you're comfortable doing it, go do it. Right? With great power comes great responsibility, though. Continuous integration, continuous deployment. So this is using automation to automatically test changes, essentially. Right? So when you make a change to software and you commit it to your version control system, it can immediately test if it compiles, run actual tests if it works as intended. even go as far as to go ahead and package it up, drop it on a server, and you've got it ready for delivery immediately in a totally automated manner. In the same way you can, if you're doing infrastructure as code, you can deploy your infrastructure exactly the same way. Traditionally, developers and operations were sort of at odds with their goals. Like, we wanted uptime, we wanted to keep things stable. Developers were charged with making changes, right? And those two are sort of at loggerheads, right? Our bonus objectives are in opposition to each other. We don't want you to make changes because I'm going to get paged in the middle of the night. Like, it's stable right now, leave it alone. Part of DevOps is the developers being responsible for their own software. They now get paged when their stuff breaks. And then once they've looked at it, if they really do need that operational expertise, then they escalate to us. It's a beautiful, beautiful world.
And I guess the thing too is that it's a paradigm shift. It's
Absolutely.
Like, yeah, I mean, you have to have that kind of thought process and training.
So I mentioned infrastructure as code. What you see here is the launch configuration for a server, right? So this is a data structure. I'm showing you what image to build the server from, what size instance to build it on, the SSH key to install on it, what firewall security groups it should use. Right down here, the script to run once it comes up. That I can basically deliver that as a data structure to an API, and Amazon will just go do all these things for me. So this is the CTO of AWS, and his saying is everything fails all the time. And I'm telling you, this is a wonderful attitude to have, right? Because, you know, traditionally, when a switch went down, right, everybody beats us up, right? Because, you know, we took everything down, right? But, you know, there's only so much you can do. I don't have the data to back it up, but I would say anecdotally, most of the outages I have had have been in redundant systems that we paid, you know, extra to have two of. They're supposed to communicate to each other and keep everything up. And in the cloud, you don't do that, right? Since you can spin up data centers at a moment's notice, spin up a second data center, a third data center, a fourth data center, and use the automation to keep, you know, whichever one is up, the active one. Nobody does this, by the way. What really happens is they stick it all in one data center in one region, and when everything goes down, well, we just blame AWS.
US East 1A.
Yep. But you know what? It's not me. I'm not blaming me anymore. And it wasn't my decision to architect it that way. So, you know, I get the full night's sleep. Pets versus cattle. This is a server analogy. With the ability to automate all these things, there becomes the idea that the traditional server that had a name that you kept in place for as long as possible, that you tended and cared for, that's a pet. Right? It's kind of like your dog. In the cloud, you're able to get the concept of cattle. So it's a whole bunch of servers out there, you know. And if we lose one, it didn't have a name. Like I might care, right? But I'm not devastated that I lost it. It happens, right? I'll get another one. Like I go down to the farmer's market and buy, you know, as many as I want, right? And I even like taking this analogy a bit further. Chickens, I don't even know how many servers I've got. You know, I might lose 10, 20, 30 servers. I don't care. My service is still up. I still have a house full of chickens, right? And, you know, I'm good. Right? Immutable infrastructure. So the idea here is when I deploy my infrastructure, it never changes. I don't go and edit my infrastructure. I don't go make DNS changes. I don't go make firewall changes, right? I don't go make any sort of changes. I have my infrastructure as code. I have my data structure that indicates what my infrastructure should be. And if I have a problem with this existing infrastructure, I just build another one that looks exactly like it and destroy the old one. Now that it has people on there, I feel a little bad about that analogy. But yeah, I can clone it, right? You want to make your development and production look the same? Well, I'll build your development environment just like production from the same data structure. I will build one for every person in this room. You can all have your own development environment. And this is something that we had a big win in, right? You can have your own development environment that matches prod. When you don't need it, you just delete it. I never did, but I always wanted to get the badge reader at the gate so that when you scanned in the morning, it could bring up your development environments. Right? Yeah, you could do it, just like my little button. It used to be that if you needed more horsepower, you got a bigger server. Now, we just get more servers. Right? And in fact, throughout the day, we can adjust the number of servers to match our load. We can watch the CPU across all our servers. If it gets above 60%, I spin up another server. Next time it gets above 60% on average across the fleet, I spin up another server. Once the entire fleet gets below, on average, say 30%, I kill a server, right? They're cattle. I don't care if one goes away. I don't want that one anymore. And I scale all the way back down. Really great if you're Food Network and turkey searches the 2 weeks leading up to Thanksgiving, quadruple the need of your server farm, or even worse, Intuit with TurboTax, right? They have a huge amount of servers they need for a relatively short period of time. And this lets them do that. Of course, automation. When everything has an API, it can all be automated. Full stack developers. So not only do you write JavaScript on the front end with Node.js, you can write JavaScript on the back end. That's a joke. But yeah, I mean, you're giving more power to your developers, so they need to learn more things, right? They need to kind of get a little more operational. Which leads us to NoOps, right? If everything's got an API and developers are doing operations, you must not need an operations staff anymore. Like, that's potentially how some people look at NoOps. I'm here to convince you otherwise, but that's what NoOps is. No operations. I think this was the guy that coined the term. I think this is where it comes from. The goal of NoOps is also to improve the process of deploying applications, but NoOps means that application developers will never have to speak with an operations professional again. NoOps will achieve this nirvana by using cloud infrastructure as a service and platform as a service to get the resources they need when they need them. Right? I talked about traditionally IT being the bottleneck between the developer and productivity. Right? Here's the nirvana that does not exist. System admins, RIP. Right? With all this infrastructure available to developers with a few clicks, I wonder what our system administrators will spend their time on. Here's a hint, fixing all the things the developers did. All right, so I argue NoOps is not the elimination of operations staff. It is true that a developer today can go to the cloud deploy an application, start taking credit cards from end users in a day. And it's a wonderful world, and that's a good thing. I would also say that most of us have probably seen the developer install Linux on his own, install Apache and PHP, and get his own server up and running without an operations staff, right? The fact that the developer can do that isn't revolutionary. The fact that he can do it in a day is revolutionary, right? But it's not really transformative with respect to operations. In my mind, NoOps is removing the necessity of the manual steps between the developer having the idea and getting it to production, right? Yeah, the term should, of course, it's a word, it's a term. When you're having a conversation with someone, you should discuss what the meaning of the word is, right? Make sure you guys are on the same page. But in my mind, the goal of NoOps, or the term of DevOps, should mean that missing operational step, right? That the developer does not have to go through operations to take things to production. And there's evidence for that, right? Netflix has NoOps, right? We have hundreds of developers. This is Adrian Cockcroft, DevOps luminary. He was the guy that took Netflix to the cloud. Like he's the guy. We have hundreds of developers using NoOps to get their code and data stores deployed to our platform as a service, and to get notified directly when something goes wrong, right? They're doing it directly, no operational step between the developer's idea and production, right? But Netflix has operations. Their developers are operating in a no-ops manner, but Netflix has a large operations staff. But what their operations staff does is things like developing Spinnaker, an open source tool that allows developers to deploy, right? So you use a Git webhook to Spinnaker, and Spinnaker will deploy your application for you, right? Without that manual step. And we're using Spinnaker as of the last few months, and seems all right. Yeah. Netflix has a lot of operations. But these no-op operations are different, right? And potentially, you might look at it as like the next generation in this IT engineering and operations history, right? In this generation, a lot of that operations work is done up front, right? Not after things are delivered, right? You create pipelines that developers can then use to deploy straight to production. I've seen some nice systems where there's a Java pipeline. It doesn't matter what idea you have, it's that you're doing it in Java. And if you simply point your Java repo at this Jenkins pipeline, it will automatically take it to production for you. It'll do security testing. You can just put any sort of testing you want in there, load testing, functional testing. And if all those tests pass, go straight to production. Those operations people create things like this that I'm gonna call products, right? That pipeline sort of becomes a product. If you're uncomfortable with that term, think of it as like a system that you've built, right? But it becomes a thing that you're kind of working on, a tool, and it's that tool that removes that manual step for developers. And it requires that the operation team, to some extent, become developers themselves, right? Because they have to be building these tools and making use of APIs, and they've got to get familiar with these sorts of ways of working. Any questions or comments about that?
So does that mean developers are spending more time learning more administrative tasks? Because I mean, I've done project management with developers who've made some very strange administrative decisions that help them write their code, but had other consequences elsewhere.
In my experience, no.
Okay.
I think it's a matter of focus. And if we want to call these two groups of developers, right, the traditional developers, the ones creating the mobile apps, the web APIs, those sorts of things, like they tend to focus on things inside their language, right? And just enough stuff outside the language to accomplish what it is they need to accomplish. On the other hand, the operations developers are more technology experts, which in my mind has been one of the key values of operations staff anyway. They understand the protocols of the internet. They understand how the internet works, and then just enough inside the language to be able to cooperate and communicate with the product developers. So it's a big world, and it is tough to be an expert on all of it, right? So yeah, so at some point, you have to have some sort of specialization. I could go into like the history of system administration, where you had a chemistry department, and then one day somebody bought them a computer, and they all started to use the computer, and the computer brought value to the department, and then it brought problems. People couldn't be quite as productive because they didn't understand the computer, but they found that one chemist who understood the computer more than anybody else, and they said, hey, your job is now to manage the computer and help everybody else use it. And that guy became the systems administrator. Still, that role still exists even in NoOps, right? You're the AWS platform expert. You're the Jenkins expert, right? You're the deployment expert. How can you prepare for a NoOps career? Follow technical blogs. The sum total of human knowledge is available online. The hard part is just figuring out what it is you need to know. But here's some good technical blogs you can start to follow. Read the Phoenix Project, a DevOps lesson in a novel.
And the Unicorn Project.
Oh yes, I'll have to update my slides. Learn configuration management, directly applicable to almost all of us in our current jobs.
What was the other, what those mentioned?
The Unicorn Project, it's by the same people.
Yeah, it's just from a different frame of view. Should I put your puppet logo?
It is Unicorn, you said?
Yes,
Yeah,
the Unicorn Project.
Yeah, don't give Andy a hard time.
Like I said, I put this together yesterday from old slides, so I did learn things. Learn to program. Like seriously, if you don't know how to program, like when I'm hiring, like that's something I just require. At least the ability to automate something. Bash scripting is great. The ability to automate things through Jenkins, right? No, I mean just understanding how to do that.
I don't know. I don't think Bash is really up to it. You can't do much with Bash.
We do a lot with
I
Bash.
hear you can make a multi-user dungeon
If you're going to learn to program, Bash, Python, and Java would be my recommendations. Bash and Python for sort of us in our industry. Java is what most enterprises tend to use. If you're in a Windows environment, it would probably be PowerShell,
Or C#.
Python, and C#. Yeah.
Maybe take a tiny peek
But
at C. I don't recommend really learning to develop
No, I don't.
it.
I love C, but I don't recommend anybody learn it. All that stuff is available online. It's a great time to be trying to learn something. Use Git for source control. This is mandatory. You're going to have to learn how to use Git. Even if you don't work with the development team, configuration management and infrastructure of code, it's a necessity for that.
Wait, I can't use SVN?
No, use Git. Git's really the standard. Like if you're going to learn something, learn Git.
A quick question on Git, so how hard is to implement that for on-prem? I know that it ties in a lot for Git for cloud stuff, but
It's surprisingly trivial,
right.
because Git supports accessing repositories over just SSH. If you have a repository on a folder you can write, you can go Git your username @ server name : wherever that file is, and it will work.
And setting up, And setting up GitLab is something you can
Okay, yeah,
do.
there you go.
You can set up GitLab in an afternoon, no
Okay.
problem, from nothing, from no knowledge.
GitLab was one of the most wonderful installs I've ever done. It really was wonderful.
Yeah, it's a really nice tool. It takes up a lot of resource though.
Learn to use the cloud, right? Even if you're not operating in the cloud, even if it's not the right tool for you, you should be using it and learning the concepts of the cloud. And while you're doing it, use CloudFormation to deploy everything. Learn infrastructure as code. Of course, you're keeping it in Git. Automate something. Right? Find a practical way to apply this. And use a CICD tool to automate your automation. Or manage your automation, whatever you want to say. That's it.
All right, thank you. And unfortunately, we're out of time. I think we got a lot of questions in, but there's plenty of time because we're actually going to, one of the perks is we invite you, if you want to speak, we invite you to the K-Town Tavern. We pick up your tab.
The real meeting starts now.
The real meeting